Good evening, students. Welcome you all on YourPedia Education. So, my dear students, please tell me, am I audible? Screen is visible? Please say yes in the chat box. Am I audible? Screen is visible? Fine. Okay. So, my dear students, welcome you all on YourPedia Education. So, in this video, we are going to discuss some of the top problems related to algorithm, data structure, and programming. So I'll take all these problems which are very relevant for the upcoming exam NIC. So my dear students, if you stay with me till the last of the lecture, then I'll provide you some of the important note points which are very free, or I can say the most important concept, or it's just like a short notes, okay, cheat sheet of algorithm and data structure, which is very helpful when you are going for your exam. Just revise those points and you will feel that yes, most of the problems are asked from that cheat sheet only. So, my dear students, start with the problem. So, as you know, YourPedia already started a 1,000 question series. Very good evening, Tejasvi. YourPedia already started a 1,000 question series, which are very relevant for NIC. And you may find out that, yes, almost we can say 90% of the problems are more or less, maybe the values are changed, but all the problems are related to these topics only. So you can see here that schedule of the 1,000 question series. You know that already TOC and compiler is already done. Right now we are go with the algorithm and data structure, then DBMS, operating system, digital with their respective dates. So my dear students, please be focused on that live lecture series. Maybe it will help you to score some more numbers. So as you know that if you are a NIC aspirant, or I can say if you are go with like any of the CSC paper, the paper may be from ISRO, DRDO, ISRO, AAI, then IOCL, or any of the exam, we, the team of YourPedia, make a book which is of cover almost 2,500 questions, or I can say more precisely approximate 2,700 questions, and the still working is going on. Book is on the updating stage. So you, if you want, you can buy this book. Next, my dear students, this is the preview of the book where you can find out 2,500 plus most MCQ which are very relevant for NIC, ISRO, BARC, HPCL, KVS, and all this stuff. So, my dear students, let's start with the first problem. You can read out the first problem and please tell me what is the correct answer for this one. Very good morning, good evening, Saurabh. So, please let me the answer. Please tell me the answer. Suppose the given function f of n is 2n cube plus 4n plus 5, and g of n is 7n 5 plus 5n plus 3 plus 12. Fine. It's 5n cube. Keep in mind it's 5n cube, not 5n 3. Now, read this statement carefully, my dear students. Let h of n be a third unknown function. Keep in mind it's an unknown function. Here f of n is given, g of n is given, but h of n is not given. So we have to find out the correct relationship. Time will start now. Please tell me, you have 1 minute, approximate 1 minute time, and please tell me what is the correct answer for this problem. We have two functions given, f of n and g of n, and we have to find out the correct relationship. If you know the asymptotic notations precisely, or you know the definition of asymptotic notations, I think you are in a position to solve this problem. Yes, what is the correct answer? Please try to eliminate the option as much as possible. Yes, any idea? We have two functions given. F of n is 2n cube plus 4n plus 5, g of n is 7n की power 5 plus 5n की power cube plus 12, and h of n is a third function which is unknown. And now we have to find out a relationship between h of n, f of n, and g of n. My dear student, this is a NIC problem. Okay, how you can take this much time? What it shows? I think are you a bit comfortable with the? Please respond. Shall I start, or you will take some more time? You want some more time, or shall I start? See, my dear students, how you can approach to the problem. See, we can say f of n is equal to big of n cube. We can say g of n equal to big of n की power 5. Now, what you can consider as a h of n? See, my dear students, you can consider h of n as n square, or n, or less than n square, or equal to n square. You can consider h of n as n की power 4, or you can consider h of n as n की power 6. Fine. Now take these values and check the relationship. See, it says that h of n, the question is all about which one is not possible. Listen carefully, my dear students. H of n is big of f of n. It means h of n is less than equal to some constant of f of n. And what is f of n? N cube. Suppose here I am taking n square, which is n cube. Fine, that is fine. Now h of n is also big of g of n. Yes, because n of n square is always less than equal to n की power 5. It means this one is the true one. Yes or no? Yes, my dear students, please respond. Are you able to solve in this way? Right. Now just take some other value like n की power 4. N की power 4 or we can go with this value. H of n is big of f of n. Okay, h of n is big of f of n. This is true. But h of n is not big of n. Big of g of n. Is it possible? Because we know that f of n is smaller than g of n. And if h of n is already more smaller than f of n, then I can say transitive property. If n square is less than equal to n cube and n cube is less than equal to n5, then n square is also less than equal to n5. And if this is the case, then I can say h of n is always big of g of n. But it says that it is big of f of n, but not h of n. Is it true? It never be true. Yes, my dear students, are you able to get my answer? Shall I repeat, or are you a bit comfortable? Please tell me in the chat box. Is it are you a bit comfortable? How you can proceed with the answer? Please do it fast. Please do it fast. It means second of the correct answer for this problem is B. Keep in mind, B is the right answer. This relation never be possible, because if n is less than n square, then n is always less than n cube. That is the answer. Yes, Saurabh? Right. So B is the correct answer for this problem. So try to just take some assumption. Okay, just take the initial values of some function and then you can start and eliminating the process. Okay. Okay, my dear students, let's move to the next problem. Now tell me, which one is true? This is a simple one. Tell me, I want which of the following is not true. Keep in mind. And please read the problems carefully. The problem statement is, which of the following statement is not true? And the first statement is, quicksort is unstable and merge sort is stable algorithm. Is it true or false? Is it true or false? Is quicksort is unstable? What do I mean by unstable? Unstable means if the elements are identical, then after sorting, their relative positions are going to be changed. But yes, in merge sort, this is going to be happen. It means the statement A is the true one. Now let's move to the second statement. Yes, tell me the answer. Please do it fast. How you can take that much amount of time? Yes, my dear students, please do it fast. Tell me the right answer. Which option is the right one? B. Okay. If we randomly choose a pivot element, see, my dear student, each time for distinct element, all the elements are distinct. That means 10, 20, 30, 40, 50, 60. And we are going to choose randomly the pivot element every time. What it says? It is all about randomized quicksort. And the best case, or in the worst case, if elements are distinct, then what it gives me? N log n only. But if elements are same, then randomized quicksort burst behavior is n square. It means B is again true. Saurabh, you are right here. You are wrong here, my dear. And Rosen, you are wrong. Sorry for that. Rosen, you are wrong. B is true, my dear. B is talk about the distinct element input sorted, and in the case of randomized quicksort, it gives me n log n. But if elements are same, like 10, 10, 10, 10, 10, and if you try to apply the randomized quicksort, then again n square time. Yes, my problem divide into two parts, having 0 element at one side and n minus 1 element at one another side. Okay, that gives me n square time. Now, for every fixed strategy to choose a pivot for quicksort, it means always, yes, my dear, it means always I am trying to select a particular location element as a pivot. Suppose I am just considering the last element as a pivot every time. Fine. So if input is sorted 10, 20, 30, 40, 50, 60, after selecting the 60 as the pivot element, and if I start to go to apply the partition algorithm, then we know that what is the property of partition algorithm? It select the pivot element, then after performing the partition algorithm, the pivot element move to its correct position. All the elements which are less than pivot are going to be at one side. All the elements which are greater than the pivot element are going to be at one side. Fine. That the subpart part is maybe sorted or not sorted. So my dear students, for every fixed strategy to choose a pivot for quicksort, we can construct a worst case input that requires n log n time. Now tell me, is it true or false? In the worst case, the input that required, now here it is not talking about the distinct element. Okay, so again it is n log n is not the true one, my dear students, because we are fixing the strategy to choose a pivot. So it is going to be order of n square. Now if we could find the median in order of n time, fine, then quicksort have the worst case complexity of n log n. That is the true one. Fine, my dear students. So the point, what is the point? Point is which of the following statement is not true? B is not true. It will take order of n square time. If randomly choose a pivot element, each time distinct element, sorry, B is the true one, but C is the false. Fine. So for this is the true, this is true, this is false, and this is true. Is there any doubt? Would you like to repeat? Shall I repeat the concept or move to the next problem? Fine. Tell me the answer of this one. In a min heap, what is the most accurate description of the worst case complexity of the operation in the min heap? I want to find out the maximum element or the largest element in a heap without removing it. I don't want to remove. Yes, this one I'll explain you after at the end of the lecture. Please solve this one. Please do it fast. See, my dear students, in a min heap, I want to find out the maximum element, but the constraint is you don't have to remove that element from the heap. Yeah, Tejasvi, I'll explain, okay? Don't worry. So tell me the time required to find the maximum element. Saurabh is saying C, Tejasvi is saying B. Tell me fast, my dear. See, my dear students, if you want to find out the maximum element in a min heap, how you can find out? We know that in a min heap, maximum element always present at the leaf node. Yes or no? Now, how many number of element in a leaf node we have? N by 2. Now, without removing these elements in an array of having size n by 2, if you want to search the maximum element, how much time it will take? N by 2, or asymptotically I can say n. So C is the right answer, my dear, not the B. Yes? Is there any doubt? Because we don't want to remove. If I want to remove, then how I'll just go with that? In min heap, delete that root element, the first minimum. In this way, you have to delete n element. One delete take log n time, n delete take n log n time. In that case, the answer is n log n. But if you haven't the permission of removing the element, then the case is order of n. Because in a min heap, maximum element present at the leaf node. So we have to scan the array from n by 2th element to the nth element. Great. Now, next. After inserting these elements into a max heap in a given sequence, the sequence is like same. Now, tell me the structure of this heap by level traversing. Tell me the answer. Please do it fast. I want to find out what is the level by level traverser after converting this input into a max heap. An element came one after another in the given sequence. Keep in mind. Do it fast. So properly perform the swap operation, my dear. C, Vivek, C is the right answer. That is the level by level traverser. First of all, you have to make a max heap and then try to traverse instead of just seeing these values. A, very good. A is the right answer. See, my dear students, the first element is 52. Listen carefully, my dear. 52, then 23. After inserting the 23, is the given tree is in max heap? Right. Then I want to insert 57. Fine. Is 57 is in a given heap? No. So I have to swap. So after swap, the element look or the tree look like this. Next, I want to insert 82. If I want to insert 82, I have to insert here, then perform the swap. So 82 will be here. Fine. And now 57 is here. Okay. I have to do it one by one. So right now 57, and then first we go with 52, then 23. Then if I want to insert 57, this is wrong. I have to perform the swap operation. Then 57, 23, 52. Now I want to insert 82. If I want to insert 82, I have to perform the swap. So 82 is here, 23 is here, again 82 is here, 57 is here, right? Now I want to insert 27. 27 is here. I want to insert 42. 42 is here because it is less than 52. Then 45. So what is the level by level traverser? 82, 57, 52. 82, 57, 52. In C also 82, 57, 52. 82, 57, 52. In all the cases, first three elements are same. Then 23. 23 is here, 23 is here, 23 is here, but D you can eliminate. After 23, 27. 27 is here, you can eliminate it. 27 is here, go. Then 42. 42 and 45. So A is the right answer. A is the right answer. Yes, my dear, is there any doubt? Shall I repeat? Fine. Let's move to the next. If you have any doubt, don't worry, my dear. So we can go with the again. Fine. Now tell me, the BFS algorithm has been implemented using the queue data structure. One possible order of visiting the node is how I can visit the node. How? Yes. No. What is no? Ruzen Numan. What is no? So shall I repeat? Okay. Fine, my dear. Please tell me the BFS. What is the right BFS? As the starting node is not given, so you can consider anything. From here, you can start with M and try to find out the correct one. It's hardly a question of 15 seconds, my dear. We know that in BFS, we are going to traverse level by level. So, according to you, C is the right answer. So, you have to save the time in these type of questions, my dear. C. What about others? Yes, Tejasvi. Your math official. Isan. A. Very good. So, see, my dear, if we start with the M, who is the child of M? R, Q, and N. It means after M, we must have, see, my dear, we must have R, Q, and N always. But here, NOP, no, that's why wrong. In case of if I start this thing with N, where is N? N is here. What are the child of N? M, Q, P, O. N after Q, M, P, O. That is the right. And B. B is the right one. Next, go with C. Because after N, first of all the child, all the, I can not the child, I can say, but the node which are directly connected to N are going to be there. Fine. Move to the C, Q, fine. Who is the direct related to Q? M, N, P. Okay, so B is wrong. B is wrong. See, my dear, because N is not directly connected to P. N is not directly connected to P, but here we have P. Yes or no? The B option is N, Q, M, P, O, R. If I start my traversing from the node N, then node N have direct connection with M, O, and Q. So all these three elements are going to be inserted in a Q. M, Q, where is O? O is after P. That's why it is wrong. Yes, 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 my dear. Now go with the C part. Tell me C is right or wrong? Q, okay. Who is that element which are directly connected to Q? M, N, P. M, N, P. Very good. Now, who is directly connected to M? R. R is there first, then N, O. C is the right answer. Go with the D. Q, fine. Next, M, N, P. M, N, P, fine. Next, O. O. Is M is directly connected to O? No. M is directly connected to R. So at the place of O, we have the R. So answer is C. Fine, my dear students. Correct answer is C. Great. Now, next. In dense graph, what is the running time of Bellman-Ford algorithm? Tell me. Fast, 5 seconds only. Tell me the time complexity of Bellman-Ford. Yes, yes, do it fast. What is the time complexity of Bellman-Ford? It's a dynamic. It uses DP. Fine. What is the answer? B. B is the right answer. What is the time complexity of Bellman-Ford? N cube. Next. Yes, it's a very important problem. A. A is not the right answer, my dear. A is V square. That is wrong. Bellman-Ford is B. Shall I explain why it is B? Shall I explain why it is B? See, my dear students, if you go with the algorithm, see, first of all, for n minus 1 time, first, whatever the number of node we have, for if I have 4 nodes, then 3 times I am executing a loop where I am trying to relax each edge every time. So I am trying to relax each edge first time, each edge second time, each edge third time. Fine, my dear students. So n into e time complexity, fine, is here. And one more time, I am again relaxing each edge. Why? To identify is there is negative weight cycle present or not. If in both these two steps, if any value changes, it means yes, negative weight cycle is present. Otherwise, it gives you the correct answer. So how much time it will take? E time. So n into e plus ne is maximum in a dense graph is n square. So n into n square is n cube. Yes or no, my dear? Fine? Yes. Let's move to the next problem. Now tell me, if I have to perform the insertion sort, fine, and this is the input. So tell me, after second iteration, what will be the output? Tell me the output after second iteration. Tell me, my dear. Yes, do it fast. Again, it's a problem of just 20 seconds. You know that how insertion sort behave. It just take the element, check with the previous one. If the current element is the smaller one, then it just perform the swap operation, otherwise not. So tell me the output after second iteration. So we are saying that A. See, my dear students, see, first two element are 8 and 34. It means output is 8, 34 and remaining element. Next element is 64. That is 8, 34 and 64. And the remaining element is 51, 32, 21. Yes or no? Now what is the case? 8, 34, 64. Is there any option? 8, 34, 64, 51, 32, 21. D is the right answer. Vivek, not A but D. Because we have to perform only 2 times. Okay, you are trying to sort the whole the element. No, I want to find the output after the second iteration. Fine. So D is the right answer. Very good. Next, please read the problem carefully. What is the best case time complexity of merge sort? You know very well. What is that? Hardly 3-second problem. Yes, yes, tell me. What is the best case time complexity of merge sort? A is the right answer. Very good. Best, worst, average, all are n log n. Right. Yes, tell me the what is the time complexity of this recurrence? Fast, fast. What is the time complexity of this recurrence? Tell me the recurrence name. This recurrence relation is for what? This is the standard recurrence relation, you know. Yes, yes, please. Why you are taking so much time? A is the wrong answer. Vivek, why you are saying A, my dear? It's wrong, na? This is the standard algorithm, na? D, again wrong. What are you doing? Rn, yes, Rn is right. Yes, n log n. This is the recurrence relation for merge sort, my dear, and the best case of quick sort. Here, n time is for merge procedure. I am trying to divide my original input n into two part, each of size n by 2. Yes, yes. Now answer is B, and this is recurrence relation for best case quick sort also. Keep in mind, this recurrence is for all the cases for merge sort and the best case for quick sort. Keep in mind. And now tell me, can you tell me this recurrence relation is for what? T of n equal to T of n by 2 plus n. Tell me, this recurrence relation, what is the output of this one? Because most of the student like just they directly analyze the problem and try to give me the answer, and which is almost every time wrong. Now tell me what is the time complexity of this recurrence relation? Tell me. That's why, my dear students, please stay with me at the end, okay? Because I am trying to give you all the recurrence relation, the standard Rn. It's wrong now, n log n. How you can say it is n log n? What are you trying to apply? I know you are saying that, sir, this things goes to log n level, each time take n time, that is n log n. But that is the wrong case, my dear. How you can go with that? And log n is again the wrong answer. Saurabh, what are you doing? How you can give me n log n or log n as answer? Can I say this is the recurrence relation for best case of finding the kth smallest element? Find kth smallest element in an array. Yes or no? And how much time it will take? Omega of n in best case. Selection procedure. Yes or no? So don't try to do these silly mistakes just by saying that yes, n by 2 log n level, every time n time. No, every time it is not taking n time. First level n time, next time n by 2 time, next time n by 2 square time. Keep in mind. So time is decreasing every time at each and every level. Are you getting my point? Yes or no? Please write why. If are you getting my point? Otherwise, I have to repeat the same thing again. Yes or no? Can I go with yes? Fine, my dear. Thank you. Thank you for responding. Now tell me. Now you have to give the right answer for this one. Okay. Tell me the recurrence relation for binary search. So stay with me till the end. So I'll at the end of the lecture I'll provide you the short notes for the algorithm. Hardly it will take 5 minutes to revise the complete algorithm. Yes, great. Tell me, my dear, what is the right answer? B. Okay. For binary search, yes, B is the right answer. Why? Because finding the mid or comparison with the mid, every time we have to perform these operations only, it will take constant amount of time, and after dividing the array into two half, I have to go, or I have to consider only one half for the next iteration. Either it may be left or right. Yes, very good, my dear. Everyone gives me the right answer. Yes. Now tell me, simple, very simple problem. Which of the following represent the max heap? Max heap. What is the property for max heap? What is the property of max heap? Which one is the right answer? C. Value of parent is always greater than equal to value of children. Right, right. Very good. So don't take that much amount of time. Okay, you have to like give me the answer within 5 seconds. What is the worst case time complexity of quicksort? Do it fast. What is that worst case time complexity of quicksort? Tejasvi, not it's not B, it's not C, but B. Okay. Yeah, B. N square, yes or no? Yes or no, my dear? Very good. Next, what is the recurrence relation for best case in quicksort? Now tell me this point. What is the recurrence relation for best case in quicksort? B, yes. Why? Because this time is for the partition algorithm. This time is for the partition algorithm. Every time my problem divide into two part, one left hand side part, one is the pivot part, and one right hand side part. All the elements which are present at the left hand side part is always less than equal to pivot. All the elements which are right hand side part is greater than equal to, yes. So B is the right answer. Very good. Next, what is the worst case? Worst case. What is the worst case, my dear? What is the worst case recurrence relation of quicksort? Do it fast. A is the right answer. Again, partition algorithm time n, all the element at the one side and remaining one side at 0, and then and the other side has n minus 1 element. Right. A is the right answer. Now tell me, this is a very good problem. Tell me, in max heap, how to find out the third largest element if my root is at level 1? Please read the question carefully. Where I can find the third largest element in a max heap? ए राइट है, किसमें बच्चे तेजस? लास्ट वाले में आपका ए राइट था, इसमें ए राइट है. फाइन. नाउ टेल मी दिस प्रॉब्लम. इन मैक्स हीप थर्ड लार्जेस्ट एलिमेंट प्रेजेंट एट व्हाट लेवल? डी. Tell me, yes. One is saying D, one is saying. Tell me, please do it fast. A, how D? Yes sir, last. See, my dear student, answer is D. How? See, in a max heap, we know that maximum element, this one, second maximum element may be here, or the tree may be like this, 80 and 90. Yes or no? Or the tree may be like this, 100, 90, 80, but here we have 70. Is there any other possibility? No. It means the third largest element, 80 at the second level, 80 at the second level, 80 at the third level. D is the right answer. Yes or no? Tejasvi, is it fine? I am talking about the max heap, not BST. Keep in mind. Yes, my dear. Tell me, is it clear to you? C is not the right answer. Anywhere but not at level 1. No, that is wrong answer. Fine. Yes, please. Tejasvi, is it fine? D is the right answer. Fine. Let's move to the next problem. Yes, you know what is the worst case time complexity of insertion. So please, my dear students, keep in mind, for TA you may find all these type of questions, very simple problems. Okay, so hardly it will take 5 seconds to give the answer. Tell me, what is the worst case time complexity insertion sort? We know that n square. Yes or no? Yes, B is the right answer. Yes, everyone, B. Very good. Now tell me the next. Yes, very good. What is the height of randomly built binary search tree? What is the height in worst case? Yes, what is the height? Read the question carefully. The height of a randomly built binary search tree. C. Tejasvi saying B. C. Ishan C. Very good. C is the right answer. Tejasvi, please read the question carefully. What are you doing? See, I am talking about BST. In BST, we know that one is root, one is left child, and one is right child. Yes or no? And in the case in the left child is always less than equal to parent, right child is always greater than equal to the parent. So how we can construct a tree? Can I construct a tree like this? Yes or no? All the right hand side element are greater than 10. All the element right hand side element of 20 are greater than 20. Yes. So answer is C. Please don't do the silly mistake in this type of problems. Okay. Please. Yes. Now again very important problem. This problem already asked in the gate also. Tell me what is the answer for merging two sorted list of size M and N. Yeah. You have to read the two word very carefully. Two sorted list, and we want a new sorted list. What is the time complexity? What is the number of comparisons? C. Very good. C. C is the right answer. Anyone have any doubt? Why is it C? Shall I explain? So total, actually the total number of comparison required is M plus N minus 1 having of list of size. Tejasvi, shall I repeat? If you want to repeat, then please write R. Please write R. Hardly it will take 20 seconds. Okay, see. Suppose we have two array which are going to be sorted 10, 20 and 30. One more array 11, 21 and 31. If you want to sort these two sorted array, these two are sorted array into a new sorted array. Okay, now just take the pointer P, just take a pointer Q. Now 10 and 11, first you have to perform the comparison between 10 and 11. Who is the smaller one? 10. Increment the pointer P. 20 and 11, 20 and 11, who is going to be here? 11. Now increment the pointer. Yes or no? Very good. Now 20 and 11, comparison is between 20 and 21. 20 and 21, who is going to be here? 20. Increment the pointer. 30 and 21, you are going to perform the comparison between 30 and 21. 21 is here, you have to increment the pointer. 30 and 31, now 30 is here, the remaining element you have to as it is, you have to put as it is. Why? Because the pointer is incremented and it is out of the boundary. So number of comparison required is 1, 2, 3, 4, 5. Total number are 6. How you can write 5? M plus n minus 1. If m and n are equal, then 2m plus n, 2n minus 1, that is order of n. Yes or no? That's why, and that is the reason that in best case and worst case, if we have two sorted array, always it will take the time as theta of n. That's why the recurrence relation for merge sort is 2t n by 2 plus n only. Fine. In the best case, in the worst case, it will take n always. Are you getting my point now? Next. Now, programming problem. Tell me the answer. Please tell me the answer of this one. What is the output of the following C program? We have an array, 2D array. So I want to find or fetch the element A of 1 of 0. Yes, very good, very good. B is the right answer. B is the right answer. How? We have a 2D array. Yes or no? First element, 2 column, 3 rows, 0, 2, 2, 1, 2, 3. So A of 1, 0th row, first row, second row. You are going for first row, 0th element, that is 2. 2 is the right answer. Very good. Next. What is the running time of this problem? Yes. And I think all of you have to be like do some mistake in that problem. I think so. Please challenge me. Give me the right answer. What is the time complexity of this problem? A log n or B n? A. Why A? See, my dear student, can you tell me this statement execute how many number of times? If my program is while, listen carefully my dear students, while n is greater than 1, n is equal to n minus 1, what is the time complexity of this program? What is the time complexity of this program? No need to write BIGO. You just mention what is it, log n or n? N. Very good. Now tell me the time complexity of this program while the same condition here, n equal to n by 2. What is the time complexity? Can I say log n? Every time dividing by 2. Very good. No need to write O. Just mention n or log n. Fine. Here log n, here n. Which one is maximum? Which one is maximum? N. So can I say n is the right answer? Because asymptotically I have to take the higher degree term. Can I say n is the right answer? Is B is right or A is right? Now tell me. I just give you the explanation. Maybe it is relevant or not. I don't know. Maybe I am trying to confuse you. But tell me, which is the right answer now? After going with the explanation, what is the right answer? Saurabh is still saying A. No, my dear Isan, please consider it as a asymptotic notation. It is big of log n, it is big of n, it is big of n log n, it is big of C. That is constant. Yes, you have to consider big O. That is sorry from my side because I am like I don't know why I am not writing here big O, but just consider big O of log n, big O of n, big O of n log n. Now tell me the right answer. Still you are go with A and that is the right answer. Fine, my dear students, because once I am just enter into the loop, n is, see my dear, this is very beautiful problem. Suppose n is 1000. Suppose n is 1000. Now, when I enter into the loop, n decreases by 1, it becomes 999. And after the next iteration, my n is become 512 or 511. You can consider anything. Okay. So it means after tracing the loop one time, I am go from n to 512. Now my n is 512. After again moving in the loop, so 511 and again half of this one 255 or 256, you can consider this one. So again n by 2 almost. Fine, my dear. That's why answer is log n, not n. So don't apply the previous case, okay? Because this execute n time, this execute n by 2 time. No, that is the wrong concept. Fine. So more effective statement is this one. Keep in mind. That's why log n. Good, very good. Now tell me, what is the time complexity of this problem? Do it fast. What is the answer? N square. N square is the right answer. Why? Because if you go with the for loop, first for loop execute n times, and here j is less than 0. What is j? 0. 0 is less than n. Then I have to increment 1 by 1. So again, while loop execute n times n into n is n square. Fine. B is the right answer. Anyone have doubt? Shall I repeat? If you want to repeat me, please write. No, order of n is wrong answer, my dear. How you can say A, Saurabh? No, B is the right answer. 0 is less than n, yes. So you can increment. Then again go with the while loop. Why while loop execute one time until this condition is not going to be false? Yes. While this condition is not going to be, until unless this condition is not going to be false, I have to execute this one now. B is the right answer, my dear. Now tell me this one again, the gate problem. Maybe you may find out in, I think in one of the exam, like element, a number of element is 200 instead of 100, and the same problem is there, and you expect the same problems. Tell me the value. Yes, A by min max algo, that is wrong. A answer is wrong, but we have to apply the min max algorithm. That is the right one. So Isan, C. Yes, my dear, C is the right answer. Yes, what about Tejasvi? What about Rizwan? And what about Saurabh? C is the right answer. Fine. Why? Because if see, my dear, listen carefully. Please note down these 3 points. Without divide and conquer technique, the number of comparison required is equal to 2n minus 2. Now, with divide and conquer technique, we have two cases. If n is even and if n is odd. If n is even, it is going to be 1.5n minus 2, and if n is odd, it is going to be 1.5n minus 1.5. Fine, my dear students, keep in mind this thing. Please note down these 3 points. So here the number of elements are even, 100, 1.5n into 100, 150 minus 2, 148. C is the right answer. And you can refer the Corman also. Hardly it's a 2 paragraph problem, so you can go with that. Fine, you can easily find out the solution here. Yes, my dear. Everyone noted down. Now tell me which of the following array is not a max heap. Do it fast. Not a max heap. Which of the following array, sorry, is a max heap? Not a max heap. No, it's a max. Which one is the max heap? Which one of the following is a max heap? First one, go with first one. 10, 20, no. Next one, 15, 3, 4, 7, violet. Next one, 25, 16, 7, 10, 3, 1, 5. C is the right answer. C is the right answer. Very good. Next. Now, find out. Please do it fast. A BST visit its key in the order 23, 7, 5, 19, 8, okay, during its pre-order. What can you say about the order in which the keys shall be visited during post-order? So, my dear student, how you can approach this problem? See, first of all, in order is given or the BST visited its key in the order, okay, during pre-order. Pre-order is given, and we know that what is in order of BST. The in order of BST is the sorted one, sorted order. So you have to construct first the tree, then you have to find out the post order. It will take 2 minutes, but try to solve this problem. So why all of, okay, so how you can solve this problem? Because you are giving me the answer so fast. So Vivek, what approach you are going to use? Isan, as you mentioned, C is the right answer. Are you constructing that BST? First of all, you have to construct the BST and then you have to give the answer, okay? Then you have to traverse the tree. Because we know that in BST, in order is sorted in nature. First of all, you have to construct the tree. Fine. So if I talk about D, is everyone get the D as answer? See, my dear, if I talk about the in order, what is the in order? In order is 5, then 7, then 8, 5 is there, 7 is there, 8 is there, then 19, 19 is there, then 23, then 67, and then 95. Now you have in order, you have pre-order. Fine. Now tell me, pre-order 23, 23 is the root. Fine. Next 7, 7 is present left of the 23. So 7 is the next element. Next 5, 5 is less than 23, less than 7. So here, next 19, 19 is left to 23 but right to 7, it means here. Next 8, 8 is less than 23, then greater than 8, greater than 7, less than, greater than 7, less than 19, that is 8 be here. Next 95 and next 67, that is the BST. Now tell me the post order. Now tell me the post order. Why, Vivek, why no? See, this is the BST na? Yes, right. Now what is the post order? First left, then right. 5, 8, 19. Is there any 5, 8, 19? D. So D is the right answer. In post order, first we traverse the left child, then right child, and then print the node. Right? That is the case. So answer, maybe I am just not okay. 5, 8, 19, 7, 67, 95, and 23. Yes, D is the right answer, my dear. Okay. Is there any doubt how I can construct this tree? Shall I repeat? Fine. Now tell me the answer of this one. Okay, we have to find out the number of collisions. Tell me the number of collisions. Let the keys into hash table of size. Okay. So we are going to use linear probing. That part is not given. Keep in mind, we are going to use here linear probing. Find linear probing. Tell me the answer. How many number of collisions you will get? 2. Very good. If we are going to use linear probing, that is, keep in mind, I'm forget to mention here. And my dear students, today we are going to discuss the DBMS questions. Okay. Sorry, tomorrow at the same time at 6 p.m. we are going to discuss DBMS most relevant problems. Okay. So Now first 75 more 10, 5. 75 is there. Now next 12, 12 more 10, 2. That is 12 is here. Next 8, fine. Next 62, 62 more 10 is 2. Collision is there. So linear probing 62 is here. So one collision. Next 83. At 3 we have the collision. We move on the fourth index. One more collision. 91, 1. 15, 5. We have collision. So we just move on the next slot, next empty slot. That is 1. So total answer is 3. D is the right answer. Very good. Next. Yeah, this one is the tricky one. Now tell me, what is the running time of this recurrence relation? What is the running time of this recurrence relation? 2t n by 2 plus n by 2 plus c. Those are frequently asked recurrence relation. But maybe you may face this type of recurrence relation also, because you cannot apply master theorem here. You are unable to apply the master theorem because b is not the greater than 1. Fine. So how you can proceed with that? Tell me the right answer. So in this case, you have to manually solve the recurrence relation. Fine. Two की power n is wrong. Order of n is wrong. Please try to solve the recurrence first. Instead of giving me the random answer, try to solve this using the substitution method. Maybe you will get your answer. Okay. Because this type of problems you will face the negative problem, negative number also. Fine. So don't try to use the hit and trial method. Please try to solve the recurrence, and then give you just after solving 2 or 3 steps, you will get to know the pattern, and then you can give me the right answer. Yes. And my dear students, listen carefully. If you already fill the like paper of CGP controller of examiner of control of design and patent, as you know, pre is already cancelled, and maybe within the like 2 week or maybe hardly with the 3 week, we may expect the pre exam, and for the main exam, now they will give you very less time. So keep in mind. So my dear students, if you are good with the pre-exam and if you want to prepare for the main exam, then you can join the live classes module of CGPTM mains exam. That is a technical subject where as you know, the pattern of CGPTM exam, that is like not the objective manner, that is descriptive in nature. You have to write the whole answer, step by step procedure. Fine. So if you want to join that module, you can go with YourPedia. So we are like already we completed one batch. We almost, or at the end of the part, like almost 90% syllabus is completed for CGPTDM exam. Fine. We already covered because we know that pre is cancelled. That's why we slow our pace. But even before pre also, we already completed almost 60% syllabus. Fine. So don't worry about that. Don't worry that yes, we have 8 to 10 subject, and how we can go with like within 1 month or within 1.5 months, how we can go with 10 subjects. Okay, don't bother about that. We are here, so we can just cover the whole syllabus within 1.5 months. That is more than sufficient. Fine. Now answer is A, my dear. Very good. Very good. See how you can see. Answer is A. Very good. So my dear students, the given is T of n is equal to 2t n minus 1 minus 1. If you want to solve the next step, then we know that 2 is here, Find what is the answer of t of n minus 1. That is t of 2t n minus 2 minus 1 and whole minus 1. Are you a bit comfortable with this statement? What is t of n minus 1? Multiply with 2, decrement one value and write minus 1. So if you solve this one, you will get 2 square t n minus 2 minus 2 minus 1. Next time 2 square, if you want to solve this recurrence relation, what you will get? 2t n minus 3 minus 1 minus 2 minus 1, which is going to be 2 cube t n minus 3 minus 2 square minus 2 की power 1 minus 2 की power 0. Yes or no? Yes. Now if you go with that, like finally we will get what? 2 की power n minus 2 की power n minus 1 minus 2 की power n minus 2 minus 2 की power n minus 3 up to 2 की power 1 minus 2 की power 0. Take the minus common, 2 की n minus, if you take the common, so n minus 1 plus 2 की power n minus 2 plus 2 की power n minus 3 plus up to 2 की power 1 plus 2 की power 0. So if you get, and this is going to be almost 2 की power n, so 2 की power n minus 2 की power n constant, so you will get order of 1 as answer. Yes or no, my dear? So order of 1 is the correct answer. Keep in mind. So by seeing this recurrence, you will easily get that, okay, 2tn minus 1 is 2 की power n. Fine. So that is the right answer. Keep in mind, my dear students. Answer is A, order of 1. Now, I think you can easily solve this problem. What is the prefix form of this one? Please do it fast. Please do it fast. And my dear, if you like the session, then please click on the like button. And in this session already, like, I just take the normal moderate type of problems. Fine, but not more than that. If you want more sessions on data structure, algorithm, DBMS or other subjects, we can go with that also. But it's up to you how much response you are giving. If you like the session, please click on the like button. Please share with your friend. Fine. Now, can I skip this problem? Are you able to find out the solution? What is the prefix of this one? Power is the highest form. So power, D and E, next C and star. That is the simple thing. Now, divide and minus, divide is more powerful than division. B, A, minus. So minus A, B, star, C, power D. Again, A is the right answer. Simple. Yes or no? Fine. Next, which data structure is needed to convert infix into postfix? Do it fast. Which data structure you required to convert infix into postfix? And first of all, why there is a need to convert infix into postfix? Because in compiler, you know that we need to convert, or compiler convert the infix expression, which we are very comfortable, to postfix, because less number of scan is required. So C is the right answer. Very good. Now tell me the value of this one. Do it fast. Tell me the value of this one. 6724 6724 plus minus and star. I think we have some more questions. Then I'll provide you the cheat sheet of algorithm. Okay. And you will get that with the description also. Okay. Maybe tomorrow. The short notes cheat sheet. Okay. Of algorithm. 6 plus 6 or minus 6. So how you can solve this problem? See, my dear. See, First of all, start scanning, that is 6, 7, 2, 4 plus minus star. Start with that, perform the plus between these two. Answer is 6, 7, 6 minus star. This is like again start scanning, 7 minus 6, 1. So 6, 1 star, 6 into 1 is 6. B is the right answer. Fine, B is the right answer. Because we are performing operator 2 minus operator 1. We are doing operand 2 operator operand 1, not the like operand 1 operator operand 2. No, that is the wrong case. Okay, from the stack we are performing last in first out concept. Okay, keep in mind. Next, yes, tell me the number of rotations required. Do it fast. For the AVL tree, total number of rotations required in the case of AVL tree. Three. All of you three. You know that AVL is a binary search tree, or I can say properly the balanced binary search tree. Is everyone get the B as answer? See, 45, fine. Then 32 left of 45. Then 26 left of this 32. So we are applying the BST. Fine, my dear. Now listen carefully. Require one right rotation. So my answer is 32, 45, and 26. Because the height of left subtree minus height of right subtree, it will be maximum. It will be like -1, 1 or 0, not more than that. But here 2 minus 1 is 0. That's why I have to perform one right rotation. Now, next element is 42 is over, 45 is over, 32 is over, 26, 55. So, where I can insert 55? Right of 45. Now, again, following the property, that is 2 minus 1 is 1. Now, after 55, I have to insert 77. It will create a problem. So, I have to perform one left rotation. Fine. So that will be 32, 26. You know, I think how I am rotating all this stuff. If you still have any doubt, you can write R so I can repeat. So here is 77. Now, next is 66, where you have to insert 66 here, because greater than 55, less than 77. So here height is 3, here height is 1. Problem create with this case. Now it's a very important problem. Are you go with RR problem, or you go with RL problem? So always keep in mind, if you have both the cases, if you have RL or RR problem, so always go with RR, because it required only one comparison, one, I can say, rotations. Okay, so it required one rotation, that way total is 3. So answer is B. Instead of going with LR, first of all you have to convert LR into RR, and then you have to perform one more rotation. So no need to go with that. Okay, it will take that will take more number of rotations. Keep in mind. So 3 is the right answer. Fine. Now next. Yes, for the tree below, what is the pre-order traversal? What is the pre-order traversal? Tell me. Do it fast. Pre-order. In pre-order, first is left, then is parent, then is right. In pre-order, first is root. Yes, yes. Fine. So 2, 7 again. Okay. 2, 6, 5, 11, 5, 9, 4. A is the right answer. A is the right answer. Yes, 272. That is 272. Fine. Now I think it is more visible. A is the right answer. Now go with this one. Suppose that the number are inserted into the in that order into a initially empty BST, and the BST uses the usual ordering. What is the in order sequence? So if I go with the in order, we know that it is BST or B tree. It is BST, and we know that in BST the in order is always sorted. Whatever the sorted case is, you can go with that. Now the twist here is there any twist? No. Okay. 6843 again unsorted. So C is the right answer. Fine. Because that is the only case. C. Very good. Next. Yes, my dear. Now tell me. It's a very important problem. Now tell me what you can give me the answer here. Int small I, int array 3 of 3, please printf array equal to star array and star array equal to a of 0. Tell me the answer. What is the output? The output is 1, or the output is value at index 0 in the array, or 0 or the error. What is the right answer? A. Everyone saying A. How A is there? 0. See, my dear students, it's a 2D matrix, and in 2D matrix we require 2 pointer to fetch the value. Otherwise, with the 1 pointer we are going to select a row. Yes or no, my dear? In which row we want to go? And the array name also give me the base address. So base address is still equal to the first row address, first row first cell address. That is only the base address. So this condition is true. This condition is always true because a of 0 gives me the address or the first cell address of first row, and that is equivalent to base address. So it give me A as answer because both the condition is true. Saurabh, it's not 0, my dear, it's A. 1 is the answer. Yes or no? Shall I explain? I think I have to explain this one. See, my dear students, what is going on? See, my dear students, it's a 2D matrix now. Fine, 3 by 3. Fine. Now, array address is, suppose array address is 1000. This one is 1002. This one is 1004. I am considering int as 2 byte. This one is 1006. This one is 1008, and this one is 1010. Fine. Now, array means base address 1000 is equal to star array. Array means I am outsiding the array. Star array means I am going to select the first row. What is the address of first row? Again 1000, because to fetch the value I require 2 star. Fine, great. Now this is true. And again star array means 1000 equal to a of 0. What do you mean by a of 0? Star a of 0. Here ARR, not a of 0, ARR, my dear. So star a plus 0, again it is 1000. That is again 1000. So 1000 is equal to 1000. Yes. So answer is A. Fine. Because to get the value I required 2 star. Now tell me the answer of this one. Match the following: Tower of Hanoi, binary search for n sorted number, heap sort, and addition of 2 matrix. Tell me the right answer. One is C. No. Is C is right? C. Yes, C is the right one. If I want to add two matrices, it requires n square time, because two matrix of size n into n is n square. So for S with 1, we have only two options. Fine. Addition of two matrix never required n log n time. And in first two cases, the option is 2, which is wrong. Now A is wrong, B is wrong. Go with C and D. Now, if I want to perform the binary search on n sorted array, n sorted numbers, that is log n, it means for Q we have 4, for Q we have 4. Out of these two, only C is the right answer. Only, not A. A is wrong. Rizwan, A is wrong. C is the right answer. Yes, tell me. This is again a gate problem, but very interesting problem. We have to find out a element which is neither the maximum nor the minimum. Explain 4. R is 4. R is not 4. What is heap sort? Given n number at the worst case, heap sort required n log n time. What is the problem with that? That is 2 only. Heap sort take n log n time. Fine. Now see, if I want to find out a element, see my dear students, if I want to find out a element which is maximum in an unsorted array, how much time required to find out a maximum element in an unsorted array? It requires n order of n time. To find out minimum element in an unsorted array, asymptotically n time. But what I have to find out? An unordered list contain distinct element, the number of comparison to find an element which is neither maximum nor minimum. Saurabh is saying A, which is wrong. Yes, my dear, tell me. I want to find out an element which is not the maximum of that array, not the minimum of that array. And it's a gate PYQ problem, very simple problem. Tell me, my dear. Order of 1. Very good. Craft, very good. See, my dear students, if you want to find out the element which is neither minimum nor maximum, just take first 3 elements, because the elements are distinct in nature. So if you take first 3 element, out of first 3 element, just compare which one is the, out of 3, just compare which one is the maximum, which one is the minimum, and the rest one is between this one. Yes or no? And with the help of that, so you cannot say that this maximum is the maximum element of the array, this element, smallest element is the smallest element of the array, but you can guarantee that this is the element, the middle element, which is neither the maximum nor the minimum. That's why just performing 2 or 3 comparisons, which requires constant amount of time. So keep in mind, my dear students, here the right answer is C, but not A. Fine, C is the right answer. Very good. Next, this is a spanning tree problem. Tell me, what is the answer? You have to perform, you have to construct the spanning tree with the help of Prim's algo. That is the important point. What is the major difference between Prim's and Kruskal? While constructing the spanning tree in Kruskal, we may get disconnected spanning tree. But in the case of Prim's algorithm, we always get the connected spanning tree. Or I cannot say the spanning tree, the connected tree. Yes, we make 2 comparison, right? So please tell me in which order I can trace so that I'll get the minimum spanning tree with the help of Prim's algorithm. Each option is visible to you, all of you? Yes, Vivek is saying C. So it means you want to start with either D or by either F node. Fine. Okay. Afterwards, who is the nearest of that or the minimum of the adjacent? F to C. Very good. Next, D to A. Where is D? Where is A? Okay. Next, A to B. Fine. Next, C to E, because C is already there. Very good. And why not you go with like B to C? Why you are taking, okay, again C2 is fine because we have to traverse E, then F to H, fine, and then G to I. But how you can reach to G? H to G, H to G, right? Yes, what is the right answer? A. One is saying A, one is saying C. Maybe more than one answer may be possible, right? So give me the right answer. But keep in mind, always while constructing the minimum cost spanning tree with the help of Prim's algorithm, keep in mind you can start from any vertices, but while constructing the spanning tree, always you get the connected tree. Keep in mind that point. Yes, yes, tell me. We have to go one by one, I think. Fine. First is AB. You are selecting AB. Fine. Next, DF. DF. This is the disconnected one. Wrong. So A is wrong. Now go with CE. You are just trying to take CE as CE. Okay, fine. Next, CF. Then you can go with CF. Fine. Next, FD. F and D. Okay. Next, DA. DA. Next, CE. Why? Okay, CE. Sorry. After going with DA, you are going AB and then GH. GH, disconnected one. How you can go with that? B is wrong. Now go with C. Go with C. DF. So DF. What is DF? This one, very good. Next, FC. It is connected. Yes, and the minimum one also to reach the F, right? Then DA. DA is the smallest distance, right, to make the connection. Then AB, right? Then CE. You already cover the C, then C is the right path. Very good. Then FH. You already cover F. To reach the H, we have one more smaller path with G, but we have to see FH. Okay. Next, GH. G to H, right? And G to I. Very good. C is the right answer. Fine, my dear students. C is the right answer. Would you like to repeat? Shall I repeat? Or you will get the C as the answer, because always keep in mind in prims the tree is connected. Okay. Next, again a gate problem, but a very interesting problem. Go with that. Tell me the answer. We have a undirected simple graph where each edge has a distinct weight and E is, here I have to write a word E. E is a particular edge of G. Which of the following statement about minimum spanning tree is true? Tell me. It's a gate problem, my dear, but very important problem regarding spanning tree. We have a graph, fine, which is undirected, simple graph, and edge weight are distinct. There is no repetition in edge weight. And we are selecting a specific edge, E, having a name E. Now tell me, Which of the following statement is true? If the lightest edge of some cycle, okay, then every MST of G. So here, my dear, I think there is a printing mistake. If here you have to write, if E is the lightest edge of some cycle in G, then every MST of G include E. Again, here you have to write, if E is the heaviest edge of some cycle in G, then every MST of G exclude E. Which one is true? First one or second one? A, B, C, or D? Or all are false? Both one and true. No. Yes, my dear. Very important problem. I think I already discussed this problem in the class also. Please read the question carefully. You have given a graph having distinct edge weight. We are selecting a edge having a name E. Now suppose E is the lightest edge of some cycle in my graph, then that edge always be present in every MST. A only. No. Next is, if E is the heaviest edge of some cycle, then that is always excluded in every MST. That is never be included in every MST. That is the second option. What you can say about this problem? Yes, I want, please give me the at least your own your answer. I want the answer from everyone. A only, one only, that is the false. Partha false. Craft false. Ishan, if you say that answer is A, that is false. Please respond. What is the correct answer of this one? Please read the question. Sir, if all edge having the same weight, then it is not necessary to be included for the case, then it would be D. So, my dear, here given that if each edge has a distinct weight, it is already mentioned that it's a gate problem, my dear. It's a gate problem, but I think you have to read the problem carefully, because intentionally I just add this problem. With that, you are able to like analyze something from this problem. That's why I just intentionally add the problem. D, neither one nor two. See, my dear students, I think I have to solve the problem. First of all, it says that, okay, now, oh, see, my dear students, I am just constructing a graph. Consider this graph. Fine. And here A, here B, here C, and here D. And spot, okay, 1, 2, 3, 4, 5, and 6. That is the weight. Now, G is a graph, distinct weight. E is a particular edge of G. Okay, you can take any A. Suppose you are taking E as this edge. Now, now how we can select E? Just go with the options. If E is the lightest edge of some cycle in G, if I take this cycle, that is A, A to B, B to C, and this edge. What is the weight? 1, 2, and 3. If E is the lightest edge of some cycle, this is a cycle, and E is the lightest edge. So it says that every MST of G include E. What is the MST of this one? A to B, B to C, that is 1. B to C, that is 1. and then 1 to 4, 1 to A to D. That is the spanning tree. Now listen, my dear students, carefully. Is 1 is included? Yes. Fine. But if you consider E as this as, why? Because if, see my dear, before that I have to mention again the problem. A, B, C, D, 1, 2, you can say 3, you can say 4, 5 and 6. Suppose you are going to consider this cycle, that is A to C, A to D, D to C, 4, 3 and 5. Fine. Now listen carefully. What is the lightest edge of this cycle? That is 3. Is 3 is included in every MST? No. That's why if E is the lightest edge of some cycle in G, yes, this is the cycle in G, and in that case 3 is the lightest edge. So then every MST of G include E? No. So A is wrong. But if E is the heaviest edge of some cycle, if it is the heaviest edge is 5. So if it is the heaviest edge, why I can go with that? Why not I can trace this path? So it never be included. That is the right answer. So only B is the right one, my dear. Only B is the right one. Everyone, yes or no, my dear? Yes, Isant, you are right. If all edges have the same weight, yes, suppose it is 111 in all the cases, then it is not necessary to be included for the case. Yes, you are right. But it is mentioning that distinct weight, my dear. Fine. So, my dear, if you have any doubt, please write the R, else we can go with the next problem. Yes, again it is a gate problem, but very important problem. Now, please tell me the right answer for this one. I'm expecting. Okay, you want, okay. And rest of the student, if you don't have the problem, then please go with this problem. Okay, please read out this problem and tell me the answer. Meanwhile, I'm just repeating the last problem. I think everyone, it's again a gate problem, but yes, it is a twisting problem. Okay. Everyone, please read out the problem and then we can go with the previous one. See, okay, very good. See, my dear students, I think the craft of is, see, they are saying that we have a graph. Okay, we have a graph A, B, C. Suppose the graph is look like this, and we have a weight 1, 2, 3, 4, 5 and 6. Fine. Now these are the weights, and it says that we are considering E. We are naming E as a particular edge. That may be this one, this one, this one, this one, and both the diagonal. It may be anything, but they are mentioning about E something. If here the E, if E is the lightest edge of some cycle in G, we are making a cycle, and in that cycle, what is the E? E is the lightest edge. First of all, just construct the minimum cost spanning tree. If I construct the minimum cost spanning tree, can I say this is the minimum cost spanning tree? Yes or no? Fine. Don't. Fine, my dear. Then it's okay. Now, here in this case, what is the answer? Yes, my dear, C is the right answer. Why? Let be a we have a complete graph with 4 vertices and their weights are like this. It may be, and like we have considered the weight between 1 to 6 only. Fine. But we can give in any order these weights to edges. The maximum possible weight, even though in general we are going to find out always the minimum weight spanning tree, but right now he's saying that please find out the maximum weight of minimum spanning tree. So here answer is C. I think, yeah, Vivek, that is the right answer. How? So I'm just constructing a graph and allotting the edges, weight of each edge. Suppose this one, 2, 3, 4, 5, and 6. And 6. Now, what is the spanning tree? This one, 2, 4. And if I construct the graph like this, 1, 2, and writing 3 here, 4, 5, and 6, then in that case, my spanning tree is 1, 2, and 3. But in that case, cost is 3 plus 2, 5 plus 1, 6. But I want the maximum cost of minimum spanning tree. That is the final answer. Because you have intentionally, I'm just considering 3, which makes the loop or cycle. Fine. That 7 is the right answer. Now go with next. Again, you can, I think you can easily find out the problem. What is the, which one is the right answer? Tell me. What is the right answer? Let W be the minimum weight of among all edge weights. We have the undirected connected graph. Fine. W be the minimum weight among all edge weight in an undirected connected graph. And we have to find out which of the following statement is false. So what is E? E is a specific edge of weight W. E is the specific edge of weight W. Now tell me what is the answer. And what is W? W is the minimum weight among all the edge weights. Listen carefully, my dear student. In this case, in this problem, they are not mentioning the answer as distinct. Keep in mind. They are not mentioning the answer as distinct. Fine. So you have to consider that point also. It means there is maybe a repetition of weight. So if E be a minimum weight among all the edges, find W be the minimum weight. If it is the minimum weight, yes, it is always part of spanning tree. But it doesn't mean that particular edge is always a part of that tree. Because there is maybe a repetition of weight. Fine. So see, my dear students, there is a case. Suppose you are considering this as a E because there is a repetition and E is the lowest minimum weight. Fine. In that case, E is not present in minimum spanning tree. But if you consider, suppose this E, it may be present, it may not be present, it may be the part of cycle. Fine. That is the main point you have to keep in mind. So there is a minimum, yes, there is a minimum spanning tree. Maybe more than one spanning tree possible. That's why A is right. If E is not in the minimum spanning tree, then in the cycle formed by adding E to T, all edges have the same weight. Yes, that's why if E is not there, because all the edge weights are same, right? Every minimum spanning tree has an edge of weight W. Yes, yes. If it is no, because E is, what is E? E has a weight W, and what is weight W? Weight is the minimum weight. E may or may not be there, but W always be there. Always keep in mind, because W is the minimum weight. Fine. So E is present in every. No, that is wrong. That is false. Again, the same problem. I think you can easily solve this problem. Please do it fast. Please do it fast. Yes. See, graph has multiple distinct spanning tree, each of cost. No, what you want? Which of the following is true? Yes, fine. The graph has unique and undirected graph G has n node. If adjacency matrix of this one is all the diagonal elements are 0, no diagonal elements are 1, it means it is a complete graph. Fine. It is a complete graph having same cost. That means graph G has no minimum cost spanning tree. That is wrong. G has a unique MST. No, more than one MST is possible if value is repeated. Fine. No. Graph G has multiple spanning tree of different cost. No, multiple spanning tree of each of cost n minus 1. That is the right answer. Now tell me, you know very well, quick sort runs n square time, fine. Bubble sort n square, fine. Merge sort order of n, wrong. Insertion sort order of n, wrong. Fine. So which one is true? First and second. A is the right answer. A is the right answer. Next, let S be a binary min heap of n element we are using with array. What is the worst case time complexity of the that we already covered? Min heap, find the maximum element given in the array. Order of n is the right answer. Yes or no? Order of n is the right answer. In previously, why A? Yes, A. In this case, A. But in this case, C is the right answer because I have to find out the maximum element in min heap, which takes order of n time. And you can go with that binary search also. Okay. So now, would you want like I just give you a fast revision of algorithm within 10 to 15 minutes? If yes, please write why. Else we can stop the session. Shall I revise the whole algorithm or give the main concept like the time complexity, recurrence relation, all this stuff? If you want, write why. Else I can stop the session. And tomorrow at the same time at 6 o'clock we go with the DBMS. Okay. Please respond. Shall I? Vikas saying no. Venkta is saying yes. Yes, yes, please, my dear. If you write more session regarding the algorithm, TOC, compiler, DBMS, we can go with that. But the point is, you have to mention in the comment section box that you want more session regarding that particular subject or that particular topic. So we can take the live session in which we are going to cover the most frequent asked question or the most relevant question for NIC. And my dear students, while reading the problem, please do one thing. Please read the question carefully. Okay, please write in the comment section box. Okay, yes, very good. So please read the problem carefully, then only you have to give the answer. I think in NIC hardly out, like if I remove the part of reasoning and aptitude, if you go with the if we can leave the part of reasoning and aptitude, hardly like 20 to 25% of problems you have to use the pen. Otherwise you can sit proper, be calm, read the question carefully, and then just mark the answer. NIC is not that much typical paper. Okay, fine. So I just give you like some important points here. So if you want to write, then you can write, otherwise you can leave the session. See, my dear students, start with the basic time complexity. If I talk about the master theorem, always keep in mind, in master theorem my recurrence is T of n is equal to a t n by b plus f of n. Now, my dear students, keep in mind, you can apply the master theorem only when a is greater than equal to 1 and b is greater than 1. Keep in mind, if this condition satisfies, then only you can apply the master theorem. And now what you have to do, you have to find out n की power log a base b one value, and you have to find out f of n. Now please do the comparison. Which one is less, which one is the greater one? That is the time complexity. C of t of n, if see, my dear student, the case 1 I am discussing, if f of n is less than n की power log a base b, then time complexity this one. If n की power log a base b is less than f of n, time complexity is this one. If both are equal, then you can add either f of n into log n, you have to multiply with log n, or you can write n की power log a base b into log n, because both are equal. You can go with anyone. Fine, just take a screenshot of this one. That is a simple case. That is the condition. You can apply master theorem only when a is greater than equal to 1, b is greater than 1. What is the reason? I already discussed in the class. What is the reason why b should be greater than 1? Next, moving towards the divide and conquer property. If you want to find out the power of an element, please instead of writing, just take the screenshot and please listen carefully. To find out the power of an element, how much time it will take? Log n. Instead of multiplying with n time, go with the divide and conquer technique, which take log n time. Next, my dear, what the linear search is? Okay, first go with binary. How much time binary search take? Worst case, big of log n. Best case, omega of 1. Linear search, worst case n, best case 1, constant. Then we can go with merge sort, theta of n log n. What is recurrence relation? T of n is equal to 2t n by 2 plus n. In each and every case, the recurrence is same, time complexity is same. Take this screenshot. When you are going for the exam, like the one day before, you can revise this cheat sheet. That is more than sufficient. Okay, fine. Next, go with quick sort. We have many cases. One is for best, one is for worst. In best case, recurrence is t of n is equal to 2t n by 2 plus n, and this n is for partition algorithm time. Every time partition algorithm take n time, which makes the best case as n log n. If I go with the worst case, t of n equal to t of n minus 1 plus n, again partition algorithm time. So this give me big of n square. Take a screenshot of this one. Next, go with heap. If we go with heap, first of all, if you want to insert an element into a heap, best case constant time, worst case log n time. To one element, for one element. One method is heapify method. What is the heapify method? To maintain the property of heap. It may be min heap, it may be max heap. How much time it will take? Log n. What is the recurrence relation? Keep in mind, my dear students, this is very, very important. This thing is given only in the core man book. Okay, so what is the recurrence relation? Even though you know the time complexity is still log n, but the recurrence relation is t of n is equal to t of 2n by 3 plus c, which is going to be again log n. Keep in mind, 2n by 3 plus c, order of c. That is very, very important. Keep in mind, it's not n by 2 plus c, it is 2n by 3 plus c. Okay, take the screenshot. Heapify method, is used to maintain the property of heap. If some element is trying to violate the property, then in the worst case we have to apply the heapify just by taking the comparison between the left child, right child, whatever the property we want to satisfy, accordingly we just perform the swap. Next, if you want to delete in a heap, how much time it will take? Theta of log n. So then build heap method. How much time it will take? You know that theta of n. Then heap sort. How much time it will take? Theta of n log n. In min heap, if you want maximum element, how much time it will take? We already covered theta of n. Same in the case of max to min. Yes, we can go with analog also. Don't worry about that. There is a dedicated live session for analog also, my dear. Fine. Next we just cover insertion sort. What is the best case? Only comparison, no swap. How many comparison? One comparison. Best case is n. Keep in mind, not n square. Worst case is n square. Fine. Next, bubble sort. Worst case n square. Selection sort. Worst case n square. Next, go with greedy. Oh, one more thing is selection procedure. Selection procedure. What we have to do? Find the kth smallest element in this case, or kth largest. So best case recurrence relation. Keep in mind, my dear, T of n is equal to, this is T of n by 2 plus n, and if you solve this problem, you will get to know as answer as n, because this n is for partition algorithm. Please refer these notes. And if I talk about the worst case, my answer is T of n is equal to T of n minus 1 plus n. Again, worst case of quicksort, which is going to be order of n square. If you find the kth smallest element, worst case n square, best case n. Fine. Next, go with min max. I already cover. Go with greedy. In greedy, you go with Huffman coding. The most important time complexity is theta of n log n, because we have to first construct the heap, then delete two element, insert one element. Then Prim's and Kruskal, the important one. Prim's, order of E log E, and that is Kruskal. That is for Kruskal. And if I talk about Prim's, that is theta of V square, V plus E, that is V square. Fine. Go with Bellman-Ford dynamic programming. Bellman-Ford we already cover, order of V cube. Go with MCM, matrix and multiplication, order of V cube. Go with Floyd-Warshall, all pair shortest path, again order of V cube. Then go with traveling salesman problem, big of 2 की power n. So these are most important LCS, longest subsequence, big of n square, m into n. Fine. So that is all about, my dear students, algorithm. Just watch these video lectures, okay? Just try to attend the live lectures. And if you have still any doubt, you can reach out to YourPedia. Fine, my dear students. So we will meet tomorrow at the same time at 6 o'clock for DBMS. So thank you so much. Please like the session if you like. If you like the session, please hit on the like button. Please click on the like button. And if you have any doubt, you can please put your queries in the description box or comment section box. Okay. Okay. Thank you, my dear. Thank you. Bye bye.